All right, so probability you guys have kind of seen in both algebra a little bit, maybe, if you got to it, or you might have seen it a tiny bit in middle school. We're not going to talk about anything super crazy in this class. We're going to still kind of keep it to the basics for the most part, and we're also going to talk about some unions of things. So like if I have the probability of one thing or another thing, how do I find that kind of probability? So your general definition of probability is the sample space with likely or equally likely outcomes. We have a probability of an event E is the ratio of the number of outcomes in a sample space. So number of outcomes in a sample space that belong to event E. And then we divide that by the total number of outcomes in our sample space. Okay. Most common example of this is if I flip a coin, right, I have a 50-50 chance of getting heads and tails every single time, right? Also dice. Dice are also very common. Same thing with cards. Cards are very common when we're talking about finding probability. For example, one we're going to talk about, in addition to finding the probability of each event, we're also going to talk about how to write the event in set notation. Set notation is just a fancy way of saying list all of the options that could happen for that event specifically. Okay, so if I'm looking at example 1, we have a single dice. I'm going to say it's a 6-sided dice because technically there's more than, a 6-sided dice out there. So we have a 6-sided dice, and we're going to write the event in set notation. So for this one, for letter A, I've got E3, that's our event, is the number showing even. Okay, so if I have a 6-sided dice, the numbers that's showing that are even would be 2, 4, and 6. That's my sample space belonging to that independent event, right? The number showing is even. So 2, 4, and 6, those are the only options of my dice that are even. So I take that total number, I've got 3. So my probability of that event happening would be 3 out of 6 total, right? Or we could write this as 1 over 2, or 0.5, or I can also write probabilities as percents. If you give me any of those 4 answers, I would be happy and I would give you full credit, okay? The number showing up is greater than 4. What would those numbers be? 5 and 6. So I've got the sample space of 5 and 6. Those are my numbers. That would be greater than 4, which is a total of just 2 out of the 6 total options, which could simplify to 1 over 3, or I could put it as a decimal, or I could put it as a percent. Other thing about probability. There's kind of some restrictions on it, right? Could I have a probability of 700? Does that make sense? No. What does probability have to be in between? 0 and 1. Yeah, or 0 and 100%, right? If we're talking percent. So you can't have a probability that is larger than 1, and you cannot have a negative probability. Okay, there's always a chance that whatever the event is will happen. Okay, go ahead and try out letter C and D for me. Write out the event space in set notation, and then write out your probability. All right, so for C, you should have gotten that the number showing is less than 7. Obviously, that's going to happen 100% of the time, no matter what dice you roll, as long as it is a 6-sided dice. And then for letter D, number showing up is 7. 7 is obviously larger than 6. So if you were trying to give me the answer in set notation of what the event would look like, the circle with a line through it just means the empty space, okay, or the empty set, okay? All right. So there's another thing in probability called the complement. The complement is exactly kind of what it sounds like. They complement each other. The complement and the probability add up to give you 1. Okay, so if I want to find the other one, I would just subtract 1 from that. So if I wanted to find the complement of letter B, the number showing is greater than 4, the complement of that would be 1 minus 2/6 or 4/6, right? Basically the probability that it is not greater than 4. That's what you're finding, right? So that's what this kind of formula here is. Just 1 minus your complement gives you your probability, or vice versa. 1 minus your probability gives you your complement. Okay, so this notation right here with P and then the A with a little apostrophe there, that is what your complement. No, it actually might be with an E. It is with an E. notation is. Okay? And before we talk about decks of cards real quick, just a quick crash course for those of us that maybe don't play a ton of cards. How many total cards are there in a deck? 52. Okay. 52 cards in a deck. How many different suits are there? 4. There are 4 different suits. We've got 2 suits that are red, 2 suits that are black. Okay, my 2 black suits here are spades. Let's see if I can draw this. Spades. Clubs. And then I've got hearts. And I've got diamonds. How many of us are big card family? Anyone? Yeah? What are your go-tos?
Spicy Uno.
Spicy Uno?
Yeah.
How do you even play Spicy Uno?
There's a game called Butthead. It's really fun.
Oh, huh. What do you play, Ollie? You said
Solitaire.
solitaire. What do you guys play, Andrew? Just whatever. Yeah. Good stuff. Okay, and then in each of those decks, how many cards are there? There are 13 cards. 13 cards each. Okay. We've got face cards, and then we've got the digits, right? So you've got 2 through 9, and then you've got 2 through 10, and then you've got Jack, Queens, Kings, and Aces, right?
So is it 14?
No, 13.
Oh, wait, no,
Yeah. 13 total. So that's for all of these, right? So if I ask you how many total 5s are there in a deck of cards, you would say 4. Okay? All right. There's your crash course. If you don't know your deck of cards, you'll need to refer to that for some of these problems, okay? All right, so example 2 says, suppose you're drawing a card from a standard and well-shuffled deck of cards. Find the probability of event E, which is the card is an ace. And then also find the complement, or E prime. So probability of the card being an ace. So probability of an ace, if we have a deck of cards, well, there's how many aces in a deck of cards? 4. Out of a total, how many cards do we have? 52. So I can leave my answer like that, or I can simplify it if I would like. But you can leave it just like that. It's fine with me. Okay? Now the complement of that, so this was technically our event E. This was P of E. Okay, so our complement would be just 1 minus 4 over 52. I do want you to simplify this, yes. So 1 minus 4 over 52, that would be, I could write 52 over 52 minus 4 over 52, which gives me a total of 48 over 52. So, because they just said like the event that we were looking at here, we're just calling that the event E, and the event that we're looking at is the card is an ace. So we're looking at the probability of the card being an ace, and then we're looking at the probability of the card basically not being an ace. That's what the complement here means. Okay, then there's also, in addition to probability, we can talk about the odds of things happening. So the probability can be expressed in terms of odds, which is the comparison of both the probability of the event and the complement happening. So for example, if the probability that it's going to snow tomorrow is 20%, then the odds we can write are the probability of it happening, which is 20%, to the probability of it not happening, which would be 80%, right? So this would be 20%, oops. Or I'm going to just say like 0.2 to 8 or 80%, sorry, 0.8. That's it as a decimal, or we could say that's, the same thing as 2 to 8 or 1 to 4. Right? So in total here there's 5 kind of chances, right? Which is where like the 20% comes from, right? 1 out of 5 total choices. That's the odds of us having a snow day. But I don't think we're going to have a snow day tomorrow. Just kidding. It's Saturday.
It's Saturday.
So, no. I don't think so. I love that. Okay, next we got a shirt is selected at random from a dark closet containing 6 blue shirts and 4 shirts that are not blue. Find the odds in favor of a blue shirt being selected. So I need to find out what are the odds of the blue shirt being selected. There's a total of how many shirts? 10. So I know 6 out of 10 would be for the probability of choosing a blue shirt. the probability of not choosing the blue shirt would be 4 out of 10. Which this could simplify to be, I could multiply these both by 10 to get 6 to 4 or 3 to 2. All right, again, another kind of card example here. So I've got a card is drawn randomly from a deck of 52 cards, but what is the probability of an event happening where the card is an ace or a spade? So there's a formula here that we have. If we have two events happening, I'm going to look at the individual events, and then I'm going to take out what is overlapped, okay? So I don't want to account things more than once, basically. So the event that I'm looking at first is the card is an ace or a spade. So we're looking at the probability of an ace or a spade, which would equal the probability of an ace plus the probability of a spade. I'm just using this formula up here. That's my event E and event F. And then I'm going to subtract the probability of the intersection of the ace and the spade. Which reminds me, I forgot to tell you what this symbol means up here. You guys have seen this U before. What is this U called? Union. A union, okay? Or we can refer to it as OR, right? This, like, upside down N. Have you guys seen this before? Okay, this is called the intersection. Okay, intersection, or you also kind of hear of it referred to as and sometimes. Okay? So we're finding the probability of an ace, probability of a spade, and subtracting the probability of both of those things together. So I have how many aces in my deck of cards? 4. So I've got 4 out of 52 plus my spade. How many spades are there in a deck of cards? 13 over 52. And then I'm going to subtract the ace of spades, right? How many ace of spades are there in a deck of cards? Just 1. So I'm going to subtract 1 over 52. Add these together, simplify it. I get 16 over 52. You could simplify that if you like. You can also just leave it like that as your answer. So that's the probability of choosing an ace or a spade out of a deck of cards. All right, letter B, the probability of a card is a 3 or it is a king. Okay, so I want to find the probability of it being a 3 or a king. Which means find the probability of pulling a 3 from your deck of cards. And then add that with the probability of pulling a king from that card, or from the deck, and then subtract that from the probability of pulling a 3 and a king. Well, can I pull a 3 and a king at the same time? No, that's not the same thing, right? So this is actually just 0 in this example, right? But how many 3s are there in a deck of cards? There's 4 3s. There are 4 kings in a deck of cards. Add those together, and I get 8 out of 52. Okay, this binomial probability we are not doing, so you can go ahead and cross that out. We will not be talking about that in this class. Okay? So we've got this example, and then I'm going to add one just because I want you to have one that's similar to kind of one that you're going to see on your, it's going to be on your quiz. It's also going to be on your homework, so I want you to have an example like that. So if we roll 2 dice, okay, these are the different combinations of rolling 2 dice. I could roll a 1-1. I could roll a 1-2. I could also roll a 2 first and then a 1. So that's what that like 1, 2 and 2, 1 notation means, right? I could roll a 1-3, a 1-4, etc., etc. Do you see how that table is kind of created? Okay. Because you're not going to have to create one that big, but you will have to be able to create on your homework like the combination of things so that you can identify like what, like there's going to be a spinner problem. Like if you spin a spinner twice and there's 3 spinners, or three spots on the spinner, if I spin a spinner and I would, get the spot 1 time, and then I would get the spot 2 the second time, or I could get the spot 1 twice, right? So you're going to have to write kind of all the different options that you could have for that to be able to answer those questions. So the first probability question you're asked is, the first dice shows a 2 or the sum of the dice is 6 or 7. So you're finding the probability of the first dice being 2, or the sum being 6 and 7, or 6 or 7, sorry. So we're going to find each of those things individually, and then we're going to have to subtract the overlap, okay? So for example, probability of the first dice being 2, okay? That means my first number in this table would have a 2, so that's the entire second row here, right? So that's a total of how many events? 6. It could happen 6 times, right? So this could happen 6 times out of a total. How many total boxes are there? Options of 36, right? So my probability of the first dice being drawn, or, being thrown as being 2, is 6 out of 36. Now, where on this table would I have sums being 6 and 7 of the 2 dice? Yeah, kind of going diagonal, right? So like 5 and 1, that would give me 6. 6 and 1 would give me 7. If I move up, 4 and 2 give me 6. 5 and 2 give me 7. 3 and 3 give me 6. 4 and 3 give me 7. 2 and 4, 3 and 4, 1 and 5, 2 and 5, and 1 and 6. All of those together add to give me 6 or add to give me 7. Okay? So in total, how many dice or how many different combinations do I have there? 11 out of 36. So I've got 11 out of 36. But if I have an or kind of probability, I have to subtract the overlap. Well, what 2 or what 4 or what how many are overlapped here? 2. There's 2 of them that are overlapped, right? These 2 options right here, 2 and 4 and 2 and 5, are overlapped. So I don't want to count them twice, so I need to subtract 2 out of 36, so I only count for them one time. Okay? Simplify this out. 6 plus 11 gives me 17, minus 2 is 15 out of 36.
Why is it 36?
What about the sum of 2 dice is at most 4? The sum of the dice is at most 4. So that means it could be the sum of, like, it could be 2, it could be 3, or it could be 4. So how many options are there in my table here that give me that? I could have 1 and 1, that's 2, right? 1 and 2 is 3. Could have 3 and 1 is 4. 2 and 2 is 4. 3 and 1 are 4, right? That's the only things that I can have for being at most 4 when I add them together, right? So in total, we have 6 out of 36. Or you could simplify it and be 1 over 6. Okay? Questions on that? Okay, then we're going to add one problem, either down below here or on the other page. And that problem, we're going to talk about some animals. Okay, let's say suppose a family. Actually, we're going to talk not about animals. Suppose a family has, oh no, we will. Let's see, dogs or cats? Dogs. Suppose a family has a pregnant dog. Okay. The probability of, what should her name be? What should the dog's name be? Samantha. Samantha's dog's puppies. Wait, the probability of Samantha's, that's the same thing. I said the same thing twice. Samantha's puppies being a girl is 1/2. Okay? Let's say Samantha had how many puppies? 8. Samantha had 8 puppies. Okay, we're going to find some different probabilities of events. Okay? The first one that we're going to find is what is the probability of Samantha having exactly 4 boy puppies. So this takes and combines the idea of the counting theory and also probability. Okay? If I think about my 8 puppies, yeah. Okay, I've got 8 puppies there. I have an option of that one puppy being either a boy or a girl. So that could have 2 options. This puppy could also have 2 options. It could be a boy or a girl. These could all be just boys or girls. So we have a total of 2 to the 8th power, which equals 256. Okay? So there's a total of 256 ways that Samantha could have these puppies. Another way that we can think about this, if you're not super convinced by that, is let's say her first puppy was either a girl or a boy. Okay? Then the second puppy would either both be a girl or a boy, and a girl or a boy. So there are 2 options for the first puppy, right? Then there now becomes 4 options when I get to the second puppy, right? Because I could have a girl and a girl, or a girl and a boy. I could have a boy and a girl, and then a boy and a boy. Those are different options that are happening, right? So when I get all the way to 8, there's a total of 256. I'm not going to continue that tree because that would be way too big, okay? So what we need to do is figure out how many exactly 4 boy puppies would be. So that means out of the 8 total puppies, we're going to choose 4 of them, and they're going to be boys. It doesn't matter the order. I could have 4 boys first. She could have had 4 boys first, and then had 4 girls. She could have had a boy, girl, boy, girl, boy, girl, okay? It doesn't necessarily matter the order. So is that going to be a combination or a permutation? Combination. Order does not matter. So we need to plug in our calculator. What is 8 choose 4? We're choosing 4 to be boys out of the 8 puppies. That gives me a number. Should be 70 on your calculator. Okay, but that's the just exactly 4 puppies, right? If I would follow this, 4 boy puppies. If I would follow this tree over here, that would be all of the options that have only 4 boy puppies, okay? Then I need to say the probability is just that times 1 over 258. Okay, so your probability of having exactly 4 boy puppies is 70 over 258. And you can leave it like that. You can simplify it. You can give it to me as a percent. Whatever you want is fine. Okay.
56.
Oh, sorry. Yep, that is exactly what I meant. Good catch. Okay. Any questions on that one? Okay, what about having exactly or just no boys? What if Samantha had all little girl puppies? So no boys. So 0 boys, right? So that would be 8 choose 0.
Isn't that 0?
Not 0. It's 1. Yep. There's only one way to select nothing. So then I just take that and times it by 1 over 256, which would be 1 over 256. That is your probability of having no boys. Okay. And then lastly, what about the probability of having, at least 6 boy puppies? Probability of having at least 6 boy puppies means I could have the probability of having 6 boy puppies, or 7 boy puppies, or 8 boy puppies, and I have to add all of those together. Okay? So I would find the probability of 6 boy puppies plus the probability of 7 boy puppies plus the probability of 8 boy puppies, and add all of those together. Which means we have to do 8 choose 6, 8 choose 7, and 8 choose 8. And each of those would be multiplied by our probability, which is that 1 over 256. Okay, so on your calculator, what do you get when you do 8 choose 6? Someone do 8 choose 7 on there too.
28.
28 for 8 choose 6. Okay.
8 for 8 choose 7.
8 choose 7 is 8, and I know 8 choose 8, that one's 1. Okay. So I'm going to multiply all these by 1 over 256. We're going to add all those together. So really, I just need to do 28 plus 8 plus 1. And that would be the total options of having at least 6 boy puppies over our 256, which is our total different combinations of all the puppies that we have if we had 8. So what's 28 plus 8 plus 1 going to give me? 37. There you go. And again, you can leave it as a fraction, decimal, percent, whichever one. I will accept all those answers. Okay?